Have you ever wondered what happens behind the scenes when you search youtube.com? The technology behind this is called DNS, also known as Domain Name System. DNS is one of the foundational protocols of the internet. Whether you end up in networking, DevOps, security, or development, you will run into it, and understanding it gives you the kind of foundational knowledge that makes everything else in IT click faster. In this video, we'll cover the most important concepts you need to understand DNS from the ground up. Every time you type a domain name into your browser, your computer has no idea what that name means on its own. If your computer sent it to your router, it would just get discarded, since your router doesn't understand it. Servers and network devices speak in numbers, called IP addresses, not words. And DNS is the one that does the translation for us. So let's say you want to go to Amazon.com. Your computer first sends a special request to the DNS server, which takes the name, looks up the matching IP address in its registry, and hands it back to your computer. Your browser then sends another request directly to the IP address of the server and loads the page. That is basically DNS. It's like the internet's phone book, working silently in the background, keeping the record of all the numbers. Now, every domain is actually made up of multiple levels, and they are read from right to left, from most general to most specific. Let's use mail.google.com as an example. There is a dot at the very end, which your browser hides. This is the root level, and it's at the top of the entire DNS system. Next level is .com. This is the top level domain, or TLD. Things like .gov, .net, .io sit here as well. Then comes Google, the second level domain. This is the level that someone actually registers and owns. And finally, Mail, which is the subdomain. The owner of google.com controls this completely. They can create as many subdomains as they want. No new registration needed. It is just a DNS record configured by the owner. Subdomains can also have multiple levels too. For example, n1.mail.google.com. Each of these levels has its own dedicated DNS server, though in practice, the second level domain and any subdomains are usually managed together on the same server. So to resolve an IP, you go top down. Each server points to the next until you reach the one with the actual records, which will send you the IP you're looking for. We call these authoritative DNS servers, which basically implies they are the source of truth and hold the actual DNS records. Now in the real world scenario, your computer won't usually query the DNS servers directly. Instead, it queries the recursive resolver. For example, Google's DNS or Cloudflare's DNS. The main purpose of these recursive resolvers is to act as a middleman. These are high-performance servers that handle the full DNS lookup on your behalf and give you the final answer. What makes them particularly fast is caching. Previously resolved queries were saved for a certain period of time, so now they can be served instantly, without repeating the full lookup. So what type of information can you actually store under your registered domain name? DNS doesn't just store IP addresses. It stores different types of records, each having a specific use. The A record is the most common one you'll see. It maps a domain name to an IPv4 address. The quad A record is the same thing as the A record, but for IPv6 addresses. The CNAME record maps one domain to another domain, rather than to an IP address. It's often called an alias record. The MX record handles email. It tells the internet where to deliver email for your domain. The TXT record can be used to store plain text. It's usually used for verification and security purposes. Using the NS record, you can specify which DNS servers are responsible for your subdomain. It essentially offloads that responsibility to those servers. So when someone looks up your subdomain, they get directed to the right place. You can also host your own DNS server in your network. For example, Pi-hole, which is a popular self-hosted DNS solution. Pi-hole allows you to set custom local DNS entries, so a domain like homeserver.local resolves to whatever IP you want. However, this would only be resolvable by hosts in your network. It also has real-time query logging, which allows you to see what every device is accessing as it happens. Pi-hole can also block ads at a DNS level, meaning no browser extension or ad blocker needs to be installed on any of your devices. However, Pi-hole is packed with many more features, which would require a separate video to be covered properly. And if you'd like to see that, let us know in the comments below.